It's my great pleasure to welcome Erik Solem for the first talk of the last session. He's CEO and co-founder of Mapillary, which, as you'll see, is building a crowdsourced mapping service. Previously to that, he was an academic professor at some point in his life and funded a company called Polar Rose that Apple bought a couple of years ago. So it's a big pleasure to welcome you, Erik. Here's your clicker.
Thank you. Is this it? Yep. Thank you. Thank you. Hi, everyone. Super excited to be here. Great conference. I've had great presentations, great conversations. So thanks, Nathan, and everyone for organizing this stuff. All right, so I'm going to talk a little bit about scalably creating maps. So I'm from Mapillary, as you heard, and Mapillary is a street imagery platform powered by collaboration and computer vision. And what that means is collaboration part is anyone can contribute. So most of it is individuals with their phones, but it's also organizations, activist groups, cities. It's our customers and our partners, and we take all of that imagery and we put it together into one big data set of street imagery from around the world. And the computer vision part is mostly what I'll be talking about today, is how we use these images and we extract information. So our mission is understanding the world's places through photos, and we do that with the help of computer vision. And so this image, for example, that you see here is from North Korea. So you can see that North Korea has great streets, many lanes, but very few cars, for example. And this might be useful information for people building maps in North Korea. Jokes aside, this is what it looks like. So anyone can collect imagery. This is from a smartphone. Someone walking down the street on a Greek island, I believe this is. And so these are still images. We take the highest resolution possible and we stitch them together. We build a 3D model locally. And with the help of that, we recognize things and we position them and we create map data. So it's both like, well, we're at Google Street View. So you can go and see what the pyramids in Mexico look like and explore them, like on this picture here. But it's also for us to extract information from these images. And so we're in 190 countries. Well, we're not in 190 countries, but the people contributing are in 190 countries. This is roughly our worldwide coverage. And about 150 million images. And so we index all of these images, and we've detected about 10 billion, just over 10 billion image regions that are labeled and indexed and searchable and available through APIs. So images come from a wide range of sources. The most common source is your smartphone. So people use our iOS or Android app, and they walk around their bike, or they put the phone up in the front window using one of those suction cup mounts. And the rest is just happens automatically. The app will take pictures and then upload them, and then we collect the images across all of these users. So some people we also support action cameras. So some people put up to 4 cameras on their cars and they drive around, and you get amazing imagery this way. But we also support all the way up to the high-end mapping rigs that cities and some companies use. So we usually say any random source. It's not really random, but like we're not in control. So we have to support everything. So here's an example. San Francisco has been mapped with action cameras. It started out with phones, but now the dense coverage you see is from people driving with action cameras. This is something we did earlier in the month. This is what Berlin looked like. This is central Berlin. And we did an experiment where we asked our community to complete the map. So we posted a challenge on Twitter and Facebook and said, can you complete the map? Because there are unmapped streets in central Berlin. And this is what happened. So they filled in all of the streets just by us saying that, well, there's stuff missing here. Can you help fix the map in this area? So this was a super exciting experiment, because it was the first time where we actually tried to direct people. Otherwise, all of the content is sort of self-motivated and self-generated. Third example, this is imagery from Amsterdam. So we actually had quite good coverage of the city from regular individuals with their phones. And then the city, on Friday, a week ago today, they uploaded 800,000 high-resolution 360 images of the entire city. And so now there's a great combination of community-sourced smartphone images stitched together in one coordinate system with high resolution, high accuracy GPS 360 imagery. And I'll show some examples of this actually. So what we do then as a business is we provide all of this. So we provide all of the images, we provide all of the data we extract from the images through APIs so that people can build stuff. And for most of our clients are in mapping and automotive, meaning that they take the data that we generate and it goes into map editing tools, for example. But it's also in apps, in navigation and routing services, and in automotive increasingly as, for now, training data for AI systems. But we also provide processing services, and once vehicles start collecting enough imagery, hopefully we're going to process some of that as well. So here's Amsterdam. I just wanted to show this example. So the city uploads imagery, and immediately after, they are indexed. So you can query and look for benches, for example, and you'll find all of the images that contain benches, or if you want to know where all of the crosswalks are, for example, they are now indexed and available. And so this happens automatically all around the world with no manual intervention. So crosswalks, as you can see, there are 360 images, so you can look around, great image quality. We can map the tunnels. You also get the overpasses and where the roads are on top of each other, whatever it's called. So automatically, and we also automatically generate a complete map of where all of the traffic signs in the city are. So we recognize traffic signs in 67 countries automatically, and when we see them in more than one image, we triangulate and we position them also on the map with real coordinates. So, I mean, it's machine-generated data, so it's not 100% accurate all the time, of course, but it's still incredibly useful data. And this is stuff that normally a city pays a lot of money to get, because they need to do inventory of everything you see in the street landscape. Someone is responsible for that thing. Someone is responsible for maintaining all of the signs and checking that they're correct and that they're still where they're supposed to be. Someone is responsible for the road surface. Someone is doing city planning. All of that, and they all capture imagery to solve this problem. But we actually help them automate. And we can give them this data back. Just a few hours after they upload the images, they can get all of the signs in their city back as map objects if they want. And so, so let me talk a little bit about how we generate that. So it's actually, fundamentally, it's two components. So one, I mentioned it briefly, we reconstruct every place in 3D. And we do this using structure from motion, photogrammetry if you're from that part of the universe. It's called different things, SLAM if you're in robotics. But essentially we build a local 3D model around each place. And we do this so that you can move around between the images, like you saw in that Greek island. Those were still images, but in order to move nicely between them and give you a pleasant experience when you're browsing and looking at the imagery, we need to have them in one coordinate system. But we also use it so that when we detect something in the image, we can position it and we know where it is. And so object recognition is the second thing, and it's two different things right now. It's, well, three, but it's mainly two. It's traffic signs, which has been trained on 67 databases from 67 countries, and it's semantic segmentation, where we label image regions with 100 classes. And then there's a third thing, which is blurring of license plates and faces, which is we detect stuff, but we actually don't do anything with it. We blur it out. So just to illustrate how it works, here's a sequence, still images taken with a phone, someone driving down a street in Le Mans, France. And these are the point clouds that are generated from those still images. And whenever we detect things here, like the lane markings or the signs, we know where they are because we can reference them in this coordinate system. So segmentation looks like this. It's a little bit of an old video, but we now index all images that come into the platform, all of the 150 million images with 100 object segmentation like this. And then you can combine the two together. So this is the segmentation and the point cloud. So the cars are colored red. The lane markings are white, I think, or purple. The signs are cyan, the trees are green, etc. Buildings are gray. And then we can combine this and make map data out of it. Points, but also sort of properties along the roads. I'm going to wait, because Nathan told me to wait and play this video all the way to the end. I usually don't. Anyway, this is the local model I was talking about. So we generate this locally so that we can reference things in one coordinate system. All right. So it takes about 11 days on our 100. We're on Amazon. Sorry, Google Cloud people in the room. We're on Amazon. We have a 100 GPU instance cluster, and it takes 11 days to reprocess everything. So it's a little bit of a pain, but it's something you need to do. And every time we upgrade something, we also want to reprocess. So it takes another 11 days to update, because everything is public, and we don't want you to access old stuff where we have a better algorithm. So we need to do this over and over. So it's a fun engineering challenge to do the segmentation, the 3D reconstruction, and the sign recognition as fast as possible on this, because it costs money as well, right? And we do them in this order. So we do the segmentation first, so we know what things to ignore when we're doing the 3D reconstruction. So we can remove cars, we can remove like sky and cloud and stuff that's not stationary, and that helps improve the 3D reconstruction as well. All right, so to do this, we created a very large training set. It's the world's largest street image segmentation data set. And this is what we train our algorithms on, but we also published it, so it's available for everyone else to use as well. So if you go to research.mapillary.com, you will find the Vistas dataset, and it's available for everyone to download and use. Also commercial research, free to use for commercial research. And so you can go in there and you can browse, you can see the world map, and you can look at things like this example here with bicycle and bus in the same image. And so we did this because we actually found out that there were no other data sets that were good enough. So we were playing with cityscapes that was mentioned here a couple times today. There are a couple other data sets that are out there, but they don't have enough variability to be useful in understanding imagery across the whole world. So they only work in a very narrow, constrained setting. And then we realized that we were sitting on the best database of imagery from around the world, with because we have the geographic variability. We're in 190 countries, but I mean Google has that too, and a couple of mapping companies have imagery like that too, but they're from one type of camera. In our case, we have thousands of different camera models with different lenses, different sensors, and all of these things. And so we actually set out to, there's a white paper on how we selected the imagery for this data set. And we wanted the maximum variability over different types of sensors, lenses, time of day, and geographic location, images from the street, images from the sidewalk. And so it's a great data set, is what I wanted to say, and you can get it. So research.mapillary.com. And what we're doing with this data set is that we have a benchmark and a workshop at CVPR next month, where we'll publish the first leaderboard on 2 challenges, so segmentation on street images and also instance-specific. And so we're going to, on a regular basis, publish state-of-the-art benchmarks on this data set. And hopefully we'll learn something about how far along we are to self-driving AI, and also know who's best. So join that one. The deadline is in 10 days from now, so you still have time. And that's all I have to say. Thank you.
Do you have any questions for Jan-Erik? Here. There's one there on the left.
Hi, Robert from Datatonic. How do you address the problem of that the data itself gets old over time? So for example, the pictures of some streets were taken a few years ago when some traffic signs came up since and so on.
Yes. So because we're referencing everything in one coordinate system. So if you drive down the street and you capture images, and I drive down the same street a month later, those will be in the same coordinate system. And the objects that we detect together, they will be referenced with your images and mine. But we also have a time travel feature, so that anytime when we see a view and we have multiple time instances of the same view, there's a little clock icon in the interface, and then you can go back in time and you can see the same view and how it changed over time. So the way we're dealing with it is we save everything. So we keep all of the images of that location over time, so that not only do we mine information about what's there, ideally we also want over time to see how those places evolved. This place used to be like this, and now it's like that. Or this thing used to be here, but it's not there anymore. Or it changed from speed limit 25 to 35 or something like that. So we keep everything. And you can, if you're querying the API, you can actually set your own criteria. I only want to see the most recent image, or I want to see images from June this year and then June last year, and then compare them if you want. Yeah. There's one more here.
Do you use any special technologies to store the images? Because I can imagine you have a huge number of them.
Yes, we have just over 150 million of them. So the images are not stored in any database, but not the features actually either, but all the metadata we extract from the images, that's stored, and we use an Elasticsearch cluster. So essentially all of our data is in a giant Elasticsearch cluster, you could say. It works. Yeah.
Yeah, Tajin from Google.
Hi.
What's the motivation of people who's uploading the image?
So question, motivation for people uploading imagery. So as I mentioned in the beginning, because the platform is open to anyone, for anyone to use. And so we have all the way from individuals up to organizations, companies, and even our customers that are contributing images to the same data set. So the motivation also varies from some people are just interested in putting their town or their neighborhood on a map. Maybe like where I live in Sweden, there's no Street View, not even Google Street View. And so, but I can fix that problem myself. And by doing that, all of that data will feed into different mapping systems, and then maybe the map will get better in my town, and I will get a chance to show my neighborhood to other people. And then if you take it one step up, and some of these individuals are also mapping geeks, by the way. So we're integrated into OpenStreetMap's editing tools and a couple of different open data initiatives. So some of them are motivated by the open data aspect of it. And then if you take it one step up to groups, it's usually activist groups in cities. So it could be people that care about accessibility or about biking infrastructure, things like that. And they take pictures because we help them solve the problem of figuring out where are the unsafe crossings, or where does the city need to fix accessibility, for example. But then you also have the city, like the example with Amsterdam here. Cities take images all the time. Usually they hire people to capture them, but we're trying to tell them that they can do it themselves. And they do it for city planning, for inventory, and all of that stuff that I mentioned before. And then we take some of the imagery comes from our customers and all the way up. So it varies, but we're trying to push everyone into this collaborative model of if you give some data, you're going to get more back. Yeah. This one here.
Hi, I'm Sasha from Babylon.
Hi.
Have you had any guerrilla users, someone who wants to use your platform in a bad way? Do you have any review process of the imagery?
So we haven't seen any examples of actually there was one example where it was actually very easy to detect. There was someone, because you can upload imagery and you could edit the EXIF data and edit the location. So someone actually uploaded so that it would spell their name on the map, but that was easily found and removed. So that's the one case we've had of sabotage that I know about. So we don't have any moderation from our side, because we're a small team, and we get hundreds of thousands of images every day, and we can't look at them. But anyone can edit the content on Mapillary. So we're sort of relying on if you see something that's not correct, you can fix it. So for example, if an image is not positioned correctly, you can move it to the right location. If you see something in the image that might violate someone's privacy, for example, we blur faces and license plates, but there might be something else in the image that's kind of sensitive. You can blur that or you can delete the image. So there's a little bit of a crowd moderation going on, but in all honesty, even the crowd can't keep up with the imagery that comes in. So it's more on a when you're offended, you fix it kind of basis. Yeah. There's something in the back there as well. Yeah. Is this my total time or is this without question?
That was just your talk time.
Okay, good.
From UCL, thanks for that. I was wondering, you mentioned you ignore so the moving parts, the cars, you kind of take them out. Here.
Yeah, okay, I see you, yeah.
Do you see maybe expanding to also looking at some of those moving objects and maybe getting some other type of analysis from them, like traffic flow or movements in parts of the city or anything like that?
Yes. A couple of interesting things. So once we have indexed all of these images, I think it will be super interesting to add like a level of abstraction API on top of that. So you can query for the raw data or you can query for some kind of summary of the data. And that might include things like what is the typical pedestrian density in this location. So it might not care about what's in one image, but if you look at images over time, is this typically an area with lots of people or not? Is this an area with lots of parked cars or not? I think when it comes to actual analysis of movements, it's a little bit harder because usually our imagery is, we have some video, but usually it's still images sampled like once a second. And so I'm not sure that would be a great data set to figure out like how people are driving and things like that. But definitely where things are and where they are during different times of day, you can get that. So we have a couple of projects that I know about that are looking at pedestrian density, for example, during different times of day. Yeah. There's one here.
Hey, Richard from Columbia.
Hi.
I really like your attitude to open data. Is there some reason commercially that you chose that, or was that just personal ethics, and how do we encourage other businesses to have a similar open data policy?
That's a great question. I mean, to me, it's a combination of ethics and common sense. So I didn't go into all of those details, but the images are actually available under a Creative Commons license if you want to use them, and you can do whatever you want with them. For me, it's more like, I mean, we're not collecting the imagery. Other people are doing it. I mean, they're self-motivated, and we help them, we give them something back, but it's still, other people are out there taking pictures and doing the work. So it kind of makes sense to also share the images under an open license. Then when it comes to mining the images and extracting data, that's actually quite expensive and a lot of work on our side. So you might consider, okay, we actually did that work, but I mean, I think it's you need to be open and you need to collaborate. If you're going to map the world at a reliable speed and with enough coverage, no one can do it alone. Like even companies like Google are struggling. Like my hometown is, for example, not mapped. I keep mentioning that. So I think collaboration is the only way to win. And if you're collaborating, you also need to be open and share stuff. So we open source most of our code as well. Yeah, did that answer your question? I forgot. There was something else at the end, but yeah. If it makes business sense, I think so. I hope so. Yeah.
Cool. On that note, let's thank Jan Erik.
All right. Thank you.